guys for coming out today. Um, so my name is Trevon. I'm a PhD candidate at UNC Charlotte. I'm a director of education at the Ethical Hacking Club on campus, and I'm a defense competition enthusiast. That's a lot. That's really where my idea to utilize automation came from, and kind of like how I got into this area of research. And I'm also super thankful to the SaltStack staff for allowing me to speak. It saved me $500, which is like 50 meals at Chipotle. So that's kind of why I'm here speaking. Um, the focus of my presentation is kind of like the body of research, how you can basically utilize defense, kind of like how I've been utilizing SALT. The applications of this design strategy is called autonomic computing, similar to like or synonymous with like autonomous, and then kind of like going over the architecture, the scope, how I implemented this, and then how I use SALT and why SALT. I think as I continue to talk about this, and if you've kind of watch the keynote, you'll start to see how like Sol is growing into kind of this tool that truly embodies the autonomic computing design philosophy, and that kind of merges both the field of IT and security in a very nice way. So autonomic computing, if you don't know, is this idea of designing computer systems to work similarly to how the nervous system of bodies, organisms works. And so in 1998, there's a paper published in Usenex about computer immunology. I'm sorry, immunology, which is about self-healing, being able to self-diagnose. And then IBM coined the term autonomic computing in 2001. The same year, there was an architecture that came out by DARPA called the SARA model, which is Survivable Autonomic Recovery Architecture. And so this model basically tries to be self-healing, self-diagnosing, self-optimizing, self-protecting, as you can see kind of the philosophy, the design philosophies that SALT is kind of growing into. And so some of the components of the environment is the SDR, which is like sensors, detectors, arbitrators, and responders. The infrastructure methodology, DIE. This is kind of a new thing that's been pushed, I guess, like pretty recently within the information security realm, within IT. It's kind of argued whether it's actually like beneficial or not. The D is for distributed, I is for immutable, E is for ephemeral. Basically, distributed systems, load balancing across multiple nodes. Ephemeral, you don't update one node continually. You have a version that you push out. Ephemeral, things can be teared down, and they're not persistent. Also, the ability to manage the environment and to respond. This is implemented through orchestration tools. And so these are the different components of kind of like autonomic environments. And so it also like entails network updates because networking is important with computer systems. So software-defined networks, something I came across to kind of utilize the dynamic routing mechanism, like how can we move a route to a different zone without interrupting service. And this was inspired by a honeypot project. The paper is called Honey Mix, which is pretty cool if you haven't read it. How they're basically simulating an attacker to many different end nodes, and then once the attacker reaches some breadth of interactivity, they determine, okay, this is the node that the attacker is interacting with the most. We're just going to redirect all this traffic there. And the attacker doesn't even realize that he's interacting with multiple nodes because it's such a seamless transfer of service. And so orchestration, this I kind of was talking about that earlier, but it requires the right intelligent implementation. So when it comes to SALT, being able to utilize reactors and beacons in a way that is good for your environment, where you're able to dynamically enforce policy that's both on the user side and network side, and reducing the reaction time of detection. So one of the big applications in terms of defense would be implementing policies as soon as an anomaly is detected within your system. A lot of people have intrusion detection systems, intrusion prevention systems that detect malicious things, but don't always respond at the time of detection. That's where orchestration is a very powerful and important tool. And so then the last kind of component is creating a feedback loop within your environment to be able to benefit both the IT and the security team. And so this deals with reducing or optimizing the resource use, making snapshots at optimal times and load balancing, but also reducing the amount amount of resources systems consume if they don't actually need it. And integrating learning logic, how can we use machine learning? I know a lot of people throw around machine learning and using orchestration and automation, but actually, like, how can we intelligently use machine learning in these environments? So I realize I'm actually speaking really fast. If anyone has any questions, definitely let me know if you're following along. Not following along. Okay. So the optimal goal is to minimize downtime, which is always the optimal goal of the IT and security teams, to have an optimal response and to react at the time of detection. So in terms of optimal response, it's important in orchestration when reacting to have a view of both local events, but then when you get to scale, like having a view of local and global events. And that was something that was kind of encapsulated within the SARA model, showing why it's important to be able to respond locally, but then also be able to respond globally. And this was kind of something that I was having a challenge with in implementing with SALT, because it gets a little bit more complex when dealing with states and grains locally, and then trying to not have that react where the grains are the same for similar machines. Also, I should caveat and note within my implementation, in my prototype, I'm in my third implementation, and so the first two iterations of my implementation, I tried to develop I guess like my own automation to see like how to use it in a defensive way. And this was inspired by a defense competition. We were participating in the DOE Cyberforce competition, which just actually happened over the weekend. And we were using Ansible to basically kick out attackers as they were attacking us. And so I figured, well, if I roll my own, develop my own environment, it should work out well enough. But that did not work out exactly as planned. And so as I started doing my research and started expanding upon the different prototypes, I realized that when you have software-defined networking, when you have orchestration, when you have defensive techniques that come into play, you need kind of like one centralized tool to kind of manage the different reaction layers. And so this is kind of like where SaltStack comes in. And so in my implementation currently, I have the top level server. I don't have a pointer, but the top level server is kind of like the server level, which is kind of just housing all of my research. And so inside of the server, I have 4 different containers running, and then each container is a cluster of containers to simulate different zones. So the 4 gray containers are each zones with their own different network policies. The red one is the master node, which contains the salt master, and it also contains the software-defined network controller, which is communicating with the salt master to change routes from the different zone clustered containers to other zone clustered containers. The goal was to kind of create some type of complexity to where the implementation kind of was in some ways realistic. And then also, not included in this diagram, there's a snort container that is having all the traffic routed back. Yes. So the design focus, I believe I don't know if I talked about it. So the design focus is mainly to update the network seamlessly. This is through implementations from Honeymix and utilizing a custom uh, beacon from the SDN controller um, back to a reactor. That I've been struggling to kind of implement, and I was going to demo it, but I couldn't. I couldn't like complete it. And then to have an ephemeral design to where my containers are templated and they dynamically get rolled out, snapshotted, and migrated. I believe the LXD formula is being integrated into SaltStack's next update. They only currently have support for creating containers, importing images, and connecting to remotes. They don't have support for initializing a cluster. That was something I was also trying to like expand upon within the formula, but I didn't get it working effectively. And so then I'm also trying to utilize Ninja for feedback loops. How like one of the other difficulties within kind of like building these defensive automations is the feedback loops. How can we create feedback loops that aren't just a bunch of nested if then loops, but also enable the learning to be able to I'm sorry, but also enabled the learning to be able to take advantage of what's going on in the environment, the information in the environment, the event bus that's being enabled in SaltStack. So some of the initial impressions that I had of SaltStack is it has very many powerful components. And so how I'm utilizing the event reactor in the beacon system is the event reactor is reacting to beacons that I'm sending from the controller, and so the controller I'm able to pull how many packets are coming in, where packets are coming from, the flows of packets. But then it's like, how do I respond based upon packets? Also have to be able to respond based on the network and on the controller specific information. And so combining the two different beaconing sources uh, has been something that's been very interesting and difficult to do because I'm not as familiar with SaltStack as probably most of the people in the room. But then also integrating external tooling has been something that's really cool. There's a talk by Mike Reeves where he talks about how he deploys security onion to multiple end nodes within an enterprise. And so I looked at this project and I was like, how can I use this soft formula to deploy security onion to newly deployed containers within the container cluster? And so why SaltStack? Why did I choose SaltStack? I mentioned that I was using Ansible, and being a student, the feature where SaltStack is master minion, but also masterless, but also can a master can talk to other masters was something that was very appealing to me. And so going the path of Ansible first, I ran into Ansible Towers, and I was like, wow, how can I use something that's free but also extendable, but then also like promises not to update the API and breaks kind of like the tooling that I have. And so that's when I found SaltStack, where a lot of the appeal came from its self-healing properties. It also uses Python, which people know is event-driven infrastructure, and then it's extremely powerful for free. And so using SaltStack in my prototype, I'm able to automate user policies, network policies, and then utilize Ninja. Right now, I currently have a lot of nested for loops for the logic for handling the beacons. I'm still trying to find a better way. I was actually last night looking into the newly released POP, trying to implement POP to basically be a communicating server between reactors, and so that I could basically just send all the sources to a Python server and then handle the logic there and then be able to communicate seamlessly without having to have multiple states implemented in my master. And so I'm moving from configuring the beacons and reactors to the pod model that was announced in the keynote. And so, as I mentioned earlier, some of the challenges were the LXD formula, getting the LXD formula to work. Or not, I'm sorry, not getting the LXD formula to work, but like the use case that I have, um, the LXD deployment of SaltStack initializer is specifically for initializing SaltStack at the first level. But I don't think many people initialize LXD containers inside of an LXD container because that's kind of unneeded complexity. But when you have minimal computer resources, and initializing a cluster inside of a container is something that provides a layer of abstraction to where I can simulate multiple nodes without having to have multiple like KVM servers running. And the network function virtualization is its own kind of rabbit hole, and enabling controller automations uh, uh, to be triggered the from Salt has been its own challenge. And I think it's interesting and important to note that IBM was on the stage at the keynote, and IBM's also a big player of, or is one of, they coined the term autonomic computing. And it's interesting, as soon as Umbra was announced, that they were implementing and rolling it out in their system. So I think it's important to think about how IBM is using this, and then also how Salt is being designed in infrastructures and how it will go forward or be used going forward. So I went through this really fast. I'm sorry about that. So in closing remarks, autonomic computing is a design methodology that bridges the gaps between both IT and security. So when it comes to defensive automations, when it comes to securing networks, it's important to not only like consider like the policies, user policies that IT members have to implement, but the security of systems. And I think like a lot of people will realize, especially in security, if they don't know it now, these automation tools that are coming out are really bridging the gap between kind of like the blue team IT teams, because it allows them to work together to kind of like mitigate problems that they each have like different perspectives on. SaltStack is enabling this autonomous design, especially with its ability to feed the event monitor into Umbra to be able to like use learning models. I think that's something that's going to be utilized a lot. I don't know how many people kind of like heard that and was like, oh, I have an implementation for it in mind. But since I'm building a prototype, I'm like, well, I have an implementation in mind. I, don't have a really good way to utilize the event bus, but now like being able to utilize the event bus to be able to move containers, snapshot, migrate, expand upon, deploy new containers based upon like learning models, I think that's very valuable. And also my code is going to be on GitHub soon. I am actually not allowed to release it because it's part of like a university project until it's finished and the paper has been, I guess, approved. And so I definitely will, I guess, like send out an announcement when I push it on GitHub. I'm sorry for going so short. Yeah, I went to wait.
Any questions or comments? Trayvon, right?
Yeah.
Yeah, for Trayvon.
Yes. Oh.
Yeah, thank you. Very interesting talk. One question: if you, from a risk perspective, if you automate reactions to certain incidents, what I gather is you do this in a kind of play style with these organized sessions where you try to attack a server and you are getting attacked. How risky can that be if you have automated reactions built in, and the attacker knows that you have something like that in place and wants you to react?
Gotcha. So in terms of risk, and I think it's important to kind of like think about this because we're seeing people attack automations now. It's how we're building automations into systems that's kind of leading attackers to like want to drive these event feedback loops.
Yeah.
I think personally, I think like the power of salt, but then also the power of like reactions lays into the design of the infrastructure. And so when you think about like what would be more beneficial for the attackers to do to drive reactions in an environment, it would be to attack the automation, right? But if your automation is built into uh, I guess like not a central node, but is distributed, right? Like you use Salt to do a master, like have masters. There's no like central master, right? Then they can attack, your automations all they want. They can attack your reactions, but
Yeah.
based upon the design structure, like you'll see feedback loops, right? But it's not going to do any, like in my opinion, it's not going to do any kind of permanent damage because of how you design the systems. And I think
Yeah.
that's the most important thing.
Yeah. That was my question from this perspective of
Yeah.
will there be feedback loops even escalating or making this problem worse than it was at the beginning? For example, a very simple thing.
Yeah.
You see that something is some anomalous TCP traffic is coming in on a port, and you react by closing that down or thereby disabling the application in a certain way. But well, if you propagate that and say, well, I've seen it there, just to be sure, I will make this impossible on nodes A to Z. Yeah, that would be. But yeah, I think
So,
it's a learning process.
yeah.
Yeah.
I think I just realized I failed to mention something as well. I think another important like aspect of like reacting ultimately is like with these autonomous systems with like reacting autonomously, it's important that when you're reacting, the system has an awareness of kind of like how it's reacting. So for example, TCP connections to a DNS or UDP connections to a DNS server wouldn't be out of normal, but like if you start seeing like an abnormal amount, you wouldn't like just cut off all connections from a DNS server. I think that the human design, but also like administrators being able to interact with it is something that's important. Yeah.
One more over here.
Just to make sure I get this, is there a way, or is it already, are the reactions statically defined, or is there a way to feed that into some kind of machine learning to where the reactions are dynamic, so that maybe to hop on the question he asked, where it's, if an attacker is planning on your reaction, it's not always static, it's not always the same, it constantly changes, so there is no way to predict that reaction.
Yeah. So currently, like in this, in my current like model, the prototype, it is static, because I hadn't figured out a way to factor in like machine learning. But then also like I'm not going to fully utilize machine learning because only utilizing machine learning leads to kind of like feedback loop creations by attackers that are malicious. And so the balance of having kind of like, okay, this is a baseline, and then also I want my learning to build off of this baseline is the optimal goal of how to react in systems, how I want to react in systems. Yeah.
Any other hands? Questions, comments? One up front.
So you kind of touched on bridging the gap from the operations roles into the security team. What would you say would be the most effective way from your perspective to get that buy-in from that security organization to starting to put in this autonomic approach to security?
Gotcha. I think as automations are I guess like put into industry, I can't really speak to it because I mean I did 2 internships, but not at the level where I'm behind the seat working for a security team. But I think as automations become more powerful and security teams are seeing like, okay, like we need to protect those, but also like we can utilize those to roll out policies that we're demanding the IT department to, I guess, like implement. I think that's kind of like the way to bridge the gap. I don't know how many people have read the Phoenix Project, but that's like a really good book where a guy is, I think he becomes the CISO. Chief Information Security. No, he's not. He's like the Chief Information Officer. He's some position. He needs to like bridge the gap between IT and security, but also like ensure that his company doesn't go under, and as they implement like a DevOps pipeline, basically they're able to kind of like appease like security, like roll out the policies, but then also like they don't have to fight as many fires because they have like a good process of being able to roll out changes in their environment. And I think kind of like as pipelines for automation become more mature, the security team kind of sees the benefit as like, okay, like we can actually, you know, help out, yeah, more effectively. Yeah.
Great. All right. Thanks, Trayvon. Great job. Please go into the app, rate the session, and let us know if you have any questions. Trayvon will be up front.
Gotcha.